Okay, Unit 2, Day 6b, we are going to work on graphs of rational functions. So these are the harder types. Yesterday we did kind of simpler types of rational functions. Today it's going to get a little crazier, but not too bad. I think it's still manageable. So just kind of remember some of these things. This first part is going to help you, basically if you can do these four things, that'll really help you out. And then obviously if you need more, you can always do test points too. So just plug some numbers in, plug in 1, 2, 3, or maybe I wonder what's going on after 10. So plug in 11 and see what value comes out, and you can plot some more points. But for the most part, this guy here, what we want to look at is we have this function over another function. What we care a lot about is the n and the m. Okay, so the highest power, the degrees of the top. Okay, so either they can be the same. We could have the one on top being larger than the one on bottom, or we could have the one on top being less than the one on bottom. Okay, so that's kind of the three scenarios with the degrees that we could see. I want to kind of run down the columns here vertically. So I'm going to talk about what if they're equal. Okay, so if they're equal, first off, if you look at these, I guess I should say I'm not going to go directly down. All of these are the same. I got the same words written in. So really these are just all the same thing. And you can find the vertical asymptotes by setting the denominator equal to 0. Okay, so you want to know what makes the bottom equal 0. So if they're equal, I want to know, so I would set the bottom, so g of x. In this case, I set g of x equal to 0. If I want to find the x-intercepts, well, these occur at the real zeros of the numerator. So the top, so I want to figure out what makes the top equal 0. Okay, so if I plug 0 in for y, the only way for this entire function, so if I plug a 0 in here, the only way it would equal 0 is if the top equals 0. So you're basically setting the top equal to 0. So I could say set top equal to 0. Okay. Now there is something important here. Notice these are all the same, all the way across. They're all the same here, but these occur at the real zeros of the numerator that are not also not reals of the denominator. If they happen to be zeros of the top and of the bottom, those are holes in the graph. Okay, those won't be any sort of x-intercepts or anything like that. These will be holes in the graph, and then same thing up here with the vertical. So if it's the top and the bottom, this is set the top or the bottom equal to 0. This is set the top equal to 0. If it's a 0 of both, then that's a hole in the graph. Then the last one is the y-intercepts here. Okay, so this is a value of f of x when x equals 0. So basically plug 0 in for x. Okay, so when x equals 0. So you plug 0 in for x. So this is plugging in 0 for all the x's you see what comes out. And that's your y-intercept. And that's kind of true for all of them. That's true of any function, not just all of these. Okay, now, so up here, when it equals 0, or I'm sorry, when n equals m, then the n behavior for this is going to be, you're going to look at the coefficients of these guys. Okay, so a sub n is the coefficient, and b sub m is the coefficient. Okay, so we're going to look at the coefficients there, and it says a ratio. So sometimes this will be a whole number, sometimes this will be a fraction. Now, when n is greater than m, so when the top has a higher power, all these things are the same. But when the top has a higher power, the n behavior has a lot of things it could do. If it is, well, basically you're just going to divide them. You're going to divide those, and whatever the quotient is, when you divide them, and we disregard the remainder, basically. So we don't worry about the remainder, we just say what's the quotient. That's going to be the n behavior asymptote. This could be a straight line, or if n is 2 or more higher, say n was 4 and m was 2, when you divide, you'll get a quadratic left over, which means you have a quadratic n behavior. So the graph's going to be following a quadratic line as it goes towards infinity and negative infinity. And then I think probably the easiest one is when n is less than m. So when the top has a lower degree than the bottom, So in other words, if the bottom wins, the horizontal asymptote will be y equals 0. And all that is, the most basic one to show is 1 over x, or you could do 1 over x squared or something like that. The bottom has a higher degree on this one. As I plug in really big numbers, the bottom is going to grow really fast. So if you divide a small number by a bigger number, you almost have nothing. If you divide a small number like a penny among 1 million people, it's a really big number, we don't get anything. Technically, there's something for all the people it's being divided among, but it's not actually anything worth, it's very close to nothing. Okay, so as the bottom grows really fast and the bottom doesn't, I could even put an x in here. X squared, and when we're talking about a million squared is a lot bigger than a million, or a billion squared is a lot bigger than a billion. So if I took a billion divided by a billion squared, it's really almost nothing. You're not really getting much, not much per item or per thing. So basically it's nothing. Now the graph will never be nothing, but it will approach nothing. Okay, so keep that in mind as we're doing this. Just look back at this table and see if that helps. So example number 1. Now I have the function, and then I have the graph over here. The graph is already there for us. I'm going to show you how it works a little bit. Okay, so the asymptotes on this one, if I cover this up and I said, what were the asymptotes? I'd say, what makes the bottom equal 0? Okay, so what makes the bottom equal 0? So it looks like 3 and negative 3. So there's going to be a vertical, sorry, I'll use my calculator to cover this up. Vertical asymptote at x equals positive and negative 3, so plus minus 3. And then if I'm looking at so vertical, and it's not going to have a horizontal asymptote because the top is 1 more. So instead of having a horizontal asymptote, this is 0 if n is less than. It's going to be a ratio. It's going to follow this guy where it has this n behavior asymptote. Not really horizontal, but it's going to be something. So I got to divide those guys. And this is going to look kind of weird. But as I'm doing it, you can look, what does it look like is going on here? So as I go to infinity, I'm following a straight line. As I go to negative infinity, it's following a straight line. I need to figure out what is that guy. So what I do is I take the top divided by, so this would be no x squareds, no x's, and nothing. And that's going to be divided by x squared plus 0x minus 9. So my first one, x cubed divided by x squared is x. I multiply that out. I get 9x as a remainder, drop the 0 down. Now 9x cannot be divided by x squared, so that's my remainder. We disregard the remainder. Okay, so all I'm looking at, this is my function for my n behavior. So y equals x. Y equals this is my n behavior asymptote. Look at that line. Crosses at 0, has a slope of 1. Y equals x. Okay. Vertical at negative 3. This guy right here. At positive 3, that's this guy right here. So there's those guys. Now, and covering up again, x-intercept. If you're trying to find the x-intercept, plug 0 in for y. It's whatever intercept you want, plug 0 in for the opposite. So if I want the x-intercept, plug 0 in for y. Now the only way that this will equal 0 is if the top equals 0. If I get a fraction, the only way for a fraction equals 0 is if the top equals 0. So I disregard the bottom. What cubed equals 0? Well, the x-intercept is going to be, so it's going to be a coordinate. Now, if it's on the x-axis, it has a 0, y. And this one's going to be 0, because 0 cubed is 0. So at 0, 0, it crosses the x-axis. Now for the y-intercept, plug 0 in for x. Y equals 0 cubed over 0 squared minus 9. That's 0 over negative 9, which is 0. So this one, if it's on the if it's on the y-axis, it has a 0x value. The y value is also 0. Kind of makes sense. The origin, look over here, goes through the origin. That's the only place it crosses the x-axis or the y-axis. Okay. Let's go on to the second example, and maybe I'll cover this up for a second. Okay, so now let's look at the vertical asymptotes. So vertical asymptotes are what makes the bottom equal 0. So a vertical asymptote would be x equals 1. So at x equals 1, there's the vertical asymptote. And then the end behavior asymptote, I got to look at the powers. Now the top is 2 more than the bottom. Now if it's more, you got to divide them to find out what the end behavior asymptote is. So this is that the middle situation here. The top is more than the bottom, so I got to divide them. And instead of doing long division on this one, that being a first power, I can do synthetic. So I'm going to do synthetic division. So 1, -3, 3, 1. If x minus 1, if I'm trying to divide by x minus 1, I'm going to use 1 as the root. Okay? So drop the 1, -2, 1, and 2. And remember, we disregard the remainder. When we're trying to find the end behavior asymptote, forget about the remainder. So this is going to be y equals x squared plus 2x, minus 2x. Let me get out my whiteout, I'll fix that. Okay, so this is a minus 2x, and then plus 1. And that guy there, if you graph it, if you look, that's going to be, it crosses, let's see, about right here. And if I plug in 0, it's going to mirror. So it's going to kind of follow this. I should make this dotted line. That's a dotted line. So if you notice, as I go to the left, and on the left, this function's following that parabola, and as I go to the right, it's on the inside following that parabola. So this parabola dictates the end behavior. Okay, so you got vertical asymptote and you got the end behavior asymptote. There's no horizontal asymptotes. There's nothing, no flat lines that are asymptotes, but there is a parabolic asymptote there. X-intercepts, plug 0 in for y. So and the only way to make the whole function equal 0 is if the top equals 0. I just use my calculator to find this one. Okay, so you could graph just this and look for the zeros, and it's at about negative 0.25, and that's this guy right here, negative 0.25. The y-intercept says plug 0 in for x. So it'd be 0 cubed plus 3 times 0 squared plus 3 times 0 plus 1. So all these are gone but the plus 1. 0 minus 1. So this is going to be negative 1. If it's a y-intercept, that means the x coordinate is 0, 0, negative 1. If you look right there, it crosses that 0, negative 1. Okay, so there's just showing you how it looks on the graph. And when I hit print, sometimes it does it. This is all supposed to be on the next page. So I'll have to copy this over. So it missed all this stuff here. And before I hit print, it looks fine. All this stuff is where it's supposed to be. And then as soon as I hit print, it shifts stuff up sometimes and it does some weird stuff. But of course, I forget to look at it before I make the 50, 60 copies I end up making. But so this is x minus 2 over x squared minus 2x minus 3. And we'll try our best with this to graph this. So first off, what's the domain? Well, the domain would tell me what x values work. And it's going to be easier to find the ones that don't work. So I'm going to try to find those asymptotes first. I'm going to go down here to asymptotes. So where are my vertical asymptotes? My vertical asymptotes are what makes the bottom equal 0. So I'm going to rewrite this on bottom as x minus 3 times x plus 1, because that's the factored form. So it looks like there's going to be a vertical asymptote x equals 3 and at x equals negative 1. Okay, so there's my vertical. So at 3, there's a vertical asymptote, and then at negative 1, a vertical asymptote. And that'll tell me then up here, so my domain is going to be from negative infinity up to negative 1, negative 1 up to 3, and then from 3 to infinity. So these are the spots where it's not. So negative 1 and 3 are no good. The range, it might be more helpful to find the end behavior asymptote also before I answer the range. It's extremely rare to have asymptotes like this and to have everything below a certain line or above a certain line. So my guess is going to be this is going to be all real numbers, just when it's set up like this. Because typically when a function goes one direction, infinity, like goes to positive infinity, it starts at negative infinity in the next one. Or vice versa. If this goes down to negative infinity, it'll start at positive infinity. The only way it doesn't do that is if this asymptote is like this asymptote. If that was a squared, then the way this ended would be the way that would start. But this one's not that case, and that's kind of a trick we'll teach you later. We'll remind you of that. So for this one, I'm going to look at what's my end behavior asymptote. Well, the bottom is higher than the top. So if you remember, that just means that as I plug really big numbers in, the bottom's going to grow so much faster than the top that when you take a small number divided by a big number, you essentially have nothing left. So y equals 0. So there's going to be, right here is my vertical asymptote, y equals 0. Okay, so again, I'll hold off on the range right now. We'll go back and answer it for sure, but I'm pretty confident it's going to be negative infinity to infinity. Now the continuities, it's these guys are discontinuities, so there are infinite discontinuities at x equals -1 and x equals 3. Increasing, decreasing. Hold off on that for a second. We'll do some more work on that. Let's see here. It does not have my intercepts. I didn't ask for intercepts, but what are my x and y intercepts? Let's do x intercepts first. Plug 0 in for y. So if I plug 0 in for y, 0 equals x minus 2. So that would be my coordinate. If it's on the x axis, it has a 0 y, and this would be a 2. So at 2, 0, it's crossing. Now if it crosses there, that means it's going to probably go down and then up forever, or it's going up and then, going down this way and up that way forever. So it's going to come down and make like an S shape going this way or that way. The y-intercept would help me. If the y-intercept's up here, it's coming down to the right. If the y-intercept's here, it's going to be going up and to the right. So my y-intercept says plug 0 in. So y equals 0 minus 2 over 0, 0, negative 3. So it's going to be 2/3. So if here's 1, it's about 2/3 right there. And the fact that it's positive tells me this is coming down like this. Now, right there is enough to tell me that the range is from negative infinity to infinity, because every y got used somewhere. Just between these two lines, it got used somewhere. Let's see. Like I told you, the kind of the trick here, 1, that's a factor once. So that means if this finished up, it's going to start down here going like this. If this finished down in 3 was a factor one time, that means it's going to start up here. So that's kind of a trick you can use. So increasing, decreasing, 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 decreasing. So it's decreasing over its entire domain. So it's going to be just a repeat of the domain. The symmetry, there's no symmetry there. It's not symmetrical about the x-axis, y-axis, about the origin, nothing. Boundness, there's no bound. There's nothing keeping it from going up and down forever. Extrema, well, it's always decreasing, so it can't have any extrema, so none. And then that end behavior then, so the limit as x approaches negative infinity, the limit as x approaches positive infinity, that end behavior asymptote tells me the answer right there. So 0 and 0. Okay, this guy. So let's do, again, let's do, I like to do intercepts and asymptotes first. So let's do vertical asymptotes. So what makes the bottom equal 0? This would be x equals plus minus 3. Okay, the top is greater, so that means my end behavior, I got to divide these to figure this out. So we'll do x cubed plus 0x squared plus 0x plus 0. Sorry if I was off the screen there. And then, oh no, so down here, and then divided by x squared plus 0x minus 9. Just now realizing that's the exact same problem that's on the front. So that's why I paused. Like, oh, I remember this. That's okay, we'll keep going. So this would be an x, so x cubed plus 0x squared minus 9x. Again, switch all these signs, I get 9x plus 0. 9x does not get divided by x squared, so that's a remainder. We ignore the remainders. So this one has end behavior, so we'll say end behavior asymptote of y equals x. Okay, so that's going to be this guy right here. Look like something like that. So end behavior of y equals x. Domain, everything except for negative 3 and 3. So negative infinity to negative 3, negative 3 to 3, and 3 to infinity. If it's following this, that means it's going to go up in one direction and down for every other direction, so this one's going to be everything. Continuity, so it has infinite discontinuity at x equals negative 3 and 3. We got to do our intercepts. Let's find our intercepts to see where it's increasing, decreasing. Get a good picture of the graph. So the x-intercepts says plug 0 in for y. 0 equals x cubed. So that would be 0 for y and 0 for x. And then the y-intercept, plug 0 in for x. So 0 over 0 minus 9 would still be 0. I plug in 0 to 0, that didn't really help a lot, did it? That just gave me the same point. Now, so when you get in this situation, and you need more, because none of this will tell me if this is coming down that way or up that way. So pick a point. Okay, you could plug in, say, 2. What is f of 2? So that'd be 2 cubed, which is 8 over 4 minus 9. That'd be 8 over negative 5. So when I plug in 2, I get a negative. So I'm down around here somewhere. That tells me it's going to follow this one that way. It's going to come up through here and go that way. Again, this asymptote, it's only a root one time, because this would be x plus 3 and x minus 3. There's no squares on bottom, so these are, roots only one, so this is going to be up here. If this finished high, it's going to start down below. Looks something like that. So increasing, decreasing. I used a calculator on this. I found where was this maximum here. So it's increasing to a point, then it's decreasing to a point, then it's increasing. It's decreasing forever in there. So I'm going to write that down and then I'll hit resume. Okay, so this negative 5.196 is right there. Actually, probably somewhere in here. The graph's not good, but that's supposed to be that point, that max. So it's increasing up to there, and then it starts increasing again right here to there. So that's at 5.196 is over here somewhere. So actually, I guess it should be more over here. It should be more like that. But I use my calculator to find the mins and maxes to tell me where it stopped increasing. Symmetry, this actually does have odd symmetry. If you rotate it 180 degrees, you have the exact same graph. Rotate it over. Boundness, none. The extrema, or these extrema I found up here. So I use a calculator to find these mins and maxes here, or local max, local min. And the end behavior, since it follows that guy right there, the end behavior as I go to the right, so the limit as x approaches infinity will be infinity, and the limit as x approaches negative infinity will be negative infinity. Going to the left's going down, going to the right's going up.